The first type of nebula is called an emission nebula. And as the name suggests, emission nebulae actually emit their own light. They glow because they are located near some very large, very powerful and very hot stars, and they're stars that are hot enough that they pour out a lot of ultraviolet radiation. And when this ultraviolet radiation hits the nebula, it actually excites the electrons in their energy levels, bumps them up to higher energy levels, and when they drop back down, they re-emit that energy in the form of light, and this is why these nebulae glow. But the same thing that makes the nebula glow guarantees that these nebulae will not be able to condense to make stars and planets and create solar systems, because remember from kinetic molecular theory that you learned back in grade 9 that when you add energy to matter, it makes the particles move faster. So remember, a nebula is typically about 10 light years away. If we wanted to take that gas and dust, that hydrogen and helium, and shrink it down to make a solar system of 3 light years, we need to pull all these particles together. But because this nebula is absorbing all this energy, the particles are moving very fast and gravity won't be able to condense them. Nevertheless, they're beautiful objects, and the color of their light comes from the different elements that are found in a nebula. Remember that the most common element in the universe is hydrogen, and the red glow that you see from many, many nebulae is a result of the electrons of hydrogen being excited. And so the red color comes from hydrogen. This particular nebula is actually called the North America Nebula, and that's because of its shape. The person who first saw this or who studied it thought it looked like North America. Here's the East Coast. We'd be up here. Here's Hudson Bay and maybe the St. Lawrence River here. This is the east coast of the US, Florida, the Gulf of Mexico. Here's California down here. This big thing here could be Labrador on steroids, increased in size and moved south. But in any case, this is called the North America Nebula. And the red color comes from hydrogen. Green in different nebulae actually comes from oxygen. So yes, there is oxygen in space, but nowhere near enough for you to breathe it, and in fact in a slightly different form than here on Earth. The second type of nebula is called a reflection nebula, and reflection nebulae always look blue. They are not emitting their own light because they're not located near any powerful stars that pour ultraviolet radiation in, but they are located near smaller, cooler stars that pour out mostly visible light, and that visible light, when it hits the matter of the nebula, some of it will actually get reflected back. What wavelengths of light get reflected back depends on the size of the particles, and in fact, the dust grains that we talked about are the perfect size to reflect back mostly the blue wavelengths of light. And so this is why reflection nebulae look blue. We will not get star formation or solar system formation here either, because even though these nebulae are not absorbing ultraviolet radiation, the visible light itself is enough to make the particles move around fast enough that gravity can't pull them together to make stars and nebulae. A famous reflection nebula is the Witch Head Nebula. That's named for the shape. You can see the witch's head here in profile. Here's the pointy chin. There's an open screaming mouth, upper lip. There's the pointed nose with a lump on it, a bump on it, and a sunken eye in the Witch Head Nebula. Oh, that's kind of cool. The place where we will expect stars to form are what are called dark nebulae. And they are called dark nebulae because they're located nowhere near any stars. So they don't absorb any light, they don't reflect any light, and that makes them very, very, very cold. They're only a couple of degrees above absolute zero. And that means the particles are moving so slowly, they're already going to be very close together, making the nebula dense enough to block out any starlight behind it. But because they're moving so slowly, gravity will be able to pull them together. One of the most famous and beautiful dark nebulae is the Horsehead Nebula over here. This is in front of an emission nebula glowing red due to hydrogen. Down here you can see a reflection nebula. But this Horsehead Nebula, just to give an idea of size, remember our entire solar system is about 3 light years across. This is anywhere from 20 to 30 light years across.